from the exercises. And then when you're ready, you can head over to the exercises in the Colab notebook where we're going to apply some of these things. So overall, the objective of these exercises is really to help us understand the different data types in R and how to work with them. Try to notice some differences between R and Python, and really build some facility and confidence with R data types and the operations that can be done in R. Okay, so we'll start with vectors. We look at matrices, and then we look at, actually we don't look at data frames, but we do look at the factors. So from here, we can just move forward with those two tasks. So just kind of tap into any knowledge that you have with those questions, those R questions, then head over to our exercises, save a copy, and drive. I have a link to several resources, so you don't have to memorize anything from R. You can reference that. And then if we do have time in class, I will go over these and provide some tips and tricks in any areas where we see obstacles coming up. And if we don't have time in class, I will record a separate video for the online students. So just a reminder, sometimes our echo recordings cut off right at 10, or no, 9:45. So Geo does these amazing video lessons by topic. So he splits them up into pieces logically, and then you're able to see a review. And if we run out of time for something, I usually make a separate video in here, so you have that to go back to or to look at as needed. Okay, I'll mention something. I just should have said this, but this is the Colab notebook. Python is the default program for Colab notebook, and there is a setting change that has to be done to write R. So when I share a notebook, a Colab notebook with you, and I'm asking you to write R code, I have preset the Colab notebook to recognize R. But if you were to open up a new Colab notebook and try to run these R commands, it would be a mess because it would not be recognized. It would be a syntax error because the Colab notebooks are set to run Python by default. So just try to keep that in mind. And I don't remember how I changed the setting. I'll have to review that. Yeah, so this is a funny looking vector. It's not very informative at all because it's numbers that are associated with different variables all in one long vector. So we have the total sales in thousands of dollars, and then we have the prices of the cars in thousands of dollars. Oh, I mean, this is in terms of, I don't remember, maybe it's more like thousands of units, I believe. So we need to turn it into a matrix, and this was on my list of things I wanted to make sure we go over. To create the matrix, we want to use the matrix function. Turns blue in R when you use a function, it should turn blue. The matrix function with the eCars vector, and then if we're turning a vector into a matrix, you're going to need to specify the number of rows, and then you're going to have this final argument that shows false. So by row equals false. So basically that means we're telling the program to combine this first part of the vector as a column with the red highlighting the wrong piece, with this second part of the vector as a column. So instead, if this said true by row equal true, we would be stacking the vectors on top of each other, and that wouldn't be right because then we would have a column that would be alternating the counts and the prices. So we can go from there. We were able to create a matrix with total sales as column and a price as a column. So that was what we wanted to do by row equals false. So if we did by row equal true, we'd have total sales stacked on top of price, and then we'd have 8 columns and 2 rows. We don't want. Okay, so problem 3 involves calculating the revenue, which could be figured out by multiplying the prices by the total sales. So this is going to start off as a vector with a C for concatenate. And then here's maybe one of those differences that you notice between R and Python. We don't start our indexing at 0, so that's always something I screw up when I'm moving from one language to another. So we can actually access the matrix total sales by comma 1, and that's how we access a column in a matrix. And then we can access the price by using column 2. So that's just a way of saying I want all of the rows for column 1 and I want all of the rows for column 2. And this calculates our revenue. So that's looking good. Let's see. Any questions about problem 4? Now, what we want to do is create a new matrix called eCars full. And we can do this by using a useful function called cbind, which is column bind. So put together, and we can do this when we have an existing matrix and you want to add on another column, and that by default is going to be added to the right side. So we can take our existing eCars matrix and bind the column called revenue, which is a single vector. No, we have multiple variable names, don't we? So I can see why, yeah, this maybe threw you off. So yeah. Sorry about that. Yep. Okay. So the eCars. Oh, so what was happening is it was going back to the eCars vector and trying to, if we were to plug in the eCars vector, we would get an error because we would be trying to add a vector of length 16 to a vector of length 8. So then we couldn't help here. Yeah, no, part of why we do these is to realize just see what kinds of mistakes can be made, and then how we can resolve them and understand a little bit why certain errors may come up. So in problem 5, we have statistical operations, and this might be another difference that you're noticing between Python and R. In R, we don't have to import statistical operations. They're all built in, and that's just because R was built for statistical analysis, so everything is included.